The James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang.
The James Webb Space Telescope just spotted something on Neptune that has astronomers completely shaken. For the first time in 35 years, we've seen dazzling auroras lighting up the planet's atmosphere. But alongside that beauty came something terrifying. Webb detected massive temperature drops, sudden atmospheric changes, and patterns that simply shouldn't exist. Neptune is behaving in ways no model predicted, and the big question is, why? Could something gigantic have collided with the ice giant, or is there an even stranger force at play out there? But these auroras revealed something far more disturbing. Evidence of changes so massive, they're rewriting everything we thought we knew about ice giants. Neptune's hidden fire. The aurora revelation. The auroras the James Webb Space Telescope captured on Neptune aren't just pretty lights, they're warning signs. Webb's March 2025 observations didn't just confirm their existence for the first time in 35 years. They revealed that Neptune's entire atmosphere is being disrupted by something huge. Think about how long astronomers have been waiting for this. Back in 1989, when Voyager 2 did its historic flyby, scientists suspected Neptune had auroras, the same kind of shimmering light shows we see near Earth's poles. But there was a problem. Voyager could only catch a glimpse, and everything since then, Hubble, ground-based telescopes, even radio data, came up empty. For decades, Neptune's auroras were the ghost story of planetary science. Everyone thought they were there, but no one could prove it. And then Webb turned its infrared eye on Neptune, and suddenly the ghost was real. The telescope captured glowing arcs of charged particles, slamming into the planet's upper atmosphere, unleashing energy in the form of auroras. But here's where things get strange. Unlike Earth, where auroras cling to the polar regions, Neptune's are spread across its mid-latitudes. It's like seeing the northern lights blazing over Florida or Cairo. That placement isn't random. It's the fingerprint of Neptune's bizarre magnetic field. Most planets keep their magnetic fields relatively aligned with their spin. Earth's field is tilted about 11 degrees. Neptune's, try 47. That tilt, combined with the fact that its magnetic field isn't even centered at the planet's core, twists the entire magnetosphere into something no other planet in our solar system has. Imagine trying to wrap a balloon with rubber bands, but every band is stretched off-center. That's Neptune's magnetic shield. It's lopsided, chaotic, and constantly shifting. And this twisted magnetosphere is exactly why Webb saw what no telescope could catch before. Neptune's auroras were hiding in plain sight, but instead of glowing brightly in visible light like Earth's, they radiate most strongly in the infrared. That meant only a telescope like Webb, designed to detect faint infrared signals billions of miles away, could finally expose them. What Webb picked up was more than just pretty arcs of light. The real smoking gun was the detection of a molecule called the trihydrogen cation molecule. On Earth, the trihydrogen cation molecule is rare, but in the upper atmospheres of giant planets, it's a key tracer of auroral activity. You don't get the trihydrogen cation molecule unless charged particles from the solar wind collide with the planet's magnetic field and atmosphere. It's like catching the footprints of an invisible intruder. You don't see the crash itself, but you see the damage left behind. And Webb didn't just detect a trace amount. It found Neptune's skies loaded with trihydrogen cation molecules, meaning the auroras are not only real, they're powerful. Now, here's the unnerving part. Powerful auroras don't just mean cool lights. They mean Neptune is being hammered by something energetic enough to bend its atmosphere out of shape. This isn't a calm, distant world quietly orbiting the sun. It's a planet under stress. And if you think stress on a frozen giant nearly 3 billion miles away doesn't matter, think again. Because Neptune's auroras are telling us its magnetic shield isn't just tilted, it's unstable. When charged particles from the solar wind slam into it, instead of being deflected cleanly, like on Earth, they scatter chaotically. That scattering drives energy deep into the atmosphere, heating some regions while leaving others to cool dramatically. And those temperature shifts? Webb's team is already saying they don't match any predictions. This is where the collision theory starts to get interesting. For a magnetic field to be this tilted, this unstable, something massive may have shaped it in the past. Scientists already suspect Neptune's tilted field is the fossil scar of a gigantic impact early in its history, the kind of cataclysmic smash that could have knocked the entire magnetic dynamo off-center. But what Webb is showing now hints that the aftershocks of that trauma aren't over. Neptune's auroras could be the visible scars of a world still recovering from something enormous hitting it. And here's the question that keeps astronomers awake. Are these auroras proof that Neptune's magnetic field is shifting again? If a collision in the distant past twisted it once, could another recent event, another impact, be stirring the pot now? Because Neptune's sudden atmospheric changes, paired with these newly detected auroras, look less like natural cycles and more like aftershocks. That's why Webb's March 2025 detection wasn't just a technical achievement, it was a revelation. After 35 years of silence, Neptune finally lit up, and what it showed us was unsettling. A magnetic field bent at impossible angles. Auroras are glowing where they shouldn't exist. A planet's atmosphere is screaming under the weight of invisible forces. And yet, this was just the beginning. Because when scientists took the next step and analyzed Neptune's temperature data, they found something that turned this discovery from fascinating to terrifying. The auroras were just the surface warning. Beneath them, Neptune's entire atmosphere was plunging into chaos. But the auroras were just the beginning. When scientists analyzed the temperature data, they discovered Neptune's atmosphere was in the grip of something unprecedented. The Great Cooling, Neptune's atmospheric time bomb. And this is where the story takes its darkest turn. Because those auroras, as strange as they are, were only the smoke. The real fire was hidden deeper in Neptune's atmosphere. What the James Webb Telescope revealed next is something no one was prepared for. Neptune's skies are collapsing into chaos. Its atmosphere has undergone the most dramatic temperature shift ever recorded on any planet. Let's rewind for context. Back in 1989, when Voyager 2 zipped past Neptune, it measured atmospheric temperatures hovering around 750 Kelvin.
Voyager spacecraft as it raced by the planet Neptune, 2.8 billion miles away, right at the edge of our solar system.
For an ice giant nearly 3 billion miles from the Sun, that was already surprising. Neptune was warmer than it had any right to be. But when Webb and other observatories remeasured decades later, the readings didn't just show a dip. They showed an absolute plunge. By 2023, the numbers had collapsed to around 358 Kelvin. That is a staggering drop, nearly 400 degrees. Imagine stepping outside on a summer day and, within minutes, the entire planet's climate nosedives to the depths of winter. That's the scale of what Neptune just went through. But it doesn't stop there. Astronomers have been monitoring Neptune's atmosphere for 17 years, and the long-term trend is just as bizarre. Between 2003 and 2018, the planet cooled globally by 8 degrees Celsius. That might sound small until you realize how stable giant planets usually are. On Earth, a global drop of even 1 or 2 degrees is enough to trigger ice ages. Neptune's atmosphere swung 4 times that amount, and not over millennia, but in less than 2 decades. And then it pulled a stunt no one saw coming. Between 2018 and 2020, just as Neptune was cooling, its south pole suddenly spiked in the opposite direction. Temperatures there shot up by 11 degrees in just 2 years. To put that into perspective, that's like Antarctica abruptly warming by a full decade's worth of climate change in the time it takes you to upgrade your phone. No model, no prediction, not even the most speculative theory said Neptune should behave like this. So, what's going on? Scientists expected Neptune's temperatures to follow a slow, steady, seasonal rhythm. Remember, a year on Neptune lasts 165 Earth years. In that timescale, its seasons should crawl along predictably, but Webb's thermal maps are showing a planet that's not following seasons at all. It's lurching, staggering, like an engine misfiring. That's why astronomers are calling it a kind of atmospheric time bomb. Neptune isn't just drifting through natural cycles, It looks like its atmosphere is destabilizing. Think about how dramatic this really is. Earth's climate scientists lose sleep over a 1-degree rise in global temperature. On Neptune, we're talking swings of 8, 11, or even hundreds of degrees in less than a human lifetime. For a world that should be locked in icy monotony, that's terrifying. And it raises a chilling question. Is Neptune's atmosphere collapsing because something gigantic just collided with it? Some researchers suspect that what Webb is catching could be the aftershock of a massive impact. Imagine a rogue object, a wayward moon, or even a captured Kuiper belt body slamming into Neptune's atmosphere, injecting chaos into its delicate balance. That could explain the wild mix of sudden cooling, local heating, and magnetic instability. But even if it's not a fresh collision, the alternative is just as unsettling. Neptune's entire climate system is breaking the rules of planetary science, and we don't know why. And here's where it gets even more haunting. These temperature shifts aren't isolated blips. They're signals of forces at work that could fundamentally alter Neptune itself. When a planet this large, this far from the Sun, starts convulsing like this, the explanation has to be something extraordinary.
They show Neptune's thin rings, faint dust bands, and 14 moons.
So the next logical question is, what exactly could be causing these massive swings? Because if it's not seasons, and if it's not just random weather, then we're staring down forces far stranger than anything we've seen in the solar system before. These temperature swings point to forces at work that could fundamentally alter Neptune. But what could cause such massive changes on a planet 30 times farther from the Sun than Earth? The solar wind connection, Neptune under assault. The culprit behind Neptune's atmospheric chaos may not be a collision at all. It may be something far stranger, an invisible force streaming through space that most of us never think about, the solar wind. Now, when we think of the Sun's power, we imagine heat and light, but the solar wind is different. It's a constant stream of charged particles, protons, electrons, and ions blasting out at hundreds of miles per second. Here on Earth, we barely notice it because our magnetic field acts like a force field, deflecting and trapping those particles high above the atmosphere. That's what gives us the northern lights. But Neptune, that's where things get wild. Remember, its magnetic field is tilted a staggering 47 degrees off its rotation axis, and worse, it's offset from the planet's core. Picture spinning a basketball with a magnet glued off-center, wobbling unpredictably with every turn. That's Neptune's magnetosphere. It doesn't create a smooth bubble like Earth's. It creates a chaotic shield that twists, tears, and reshapes constantly. So, what happens when the solar wind slams into this crooked, unstable shield? Webb's aurora detection gave us the answer. Instead of being smoothly deflected at the poles, charged particles are injected deep into Neptune's mid-latitudes, heating some regions and cooling others. It's like a cosmic battering ram, pounding Neptune's atmosphere in random places, destabilizing the entire system. And this is when things become even stranger. Neptune's atmospheric turbulence appears to correspond to the Sun's 11-year solar cycle. Every 11 years, the Sun goes from quiet to hyperactive, releasing stronger winds, solar flares, and coronal mass ejections. And astronomers studying Neptune's clouds discovered something strange. When the Sun's activity changes, so do Neptune's cloud patterns and temperatures. When the Sun shines brightly, Neptune's methane clouds often fade away. When it calms down, the clouds return. Even though Neptune is 30 times farther away from Earth, its charged particles are powerful enough to cause havoc in the skies.
We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system.
Think about that for a second. A planet almost 3 billion miles away, orbiting in the frozen dark, still dances to the rhythm of our Sun. If the solar wind can reach out that far, what else is it capable of influencing? And Neptune isn't alone in this bizarre category. It has a magnetic twin, Uranus. Same tilted, off-center magnetic field. Same chaotic auroral patterns. Both giants, both knocked off balance by some ancient cataclysm, are now left with magnetospheres that barely function as shields. This means both planets act almost like raw test cases of how solar wind can shred a planet's atmosphere when the magnetic defenses are broken. This is where Webb's findings carry huge implications. If Neptune's atmospheric collapse is tied to solar-wind interactions, then every exoplanet we've discovered with a tilted or unstable magnetic field might face the same fate. Imagine all those distant worlds we're so excited to call potentially habitable. Without a strong, centered magnetic shield, they'd be bombarded, their atmospheres stripped or twisted, their climates plunged into chaos. Neptune may be a warning shot about how fragile atmospheres really are under stellar assault, and for us watching from Earth, it's a haunting reminder. Because if a world 30 times farther from the Sun than we are can still be thrown into chaos by solar activity, what does that say about the true reach of our star? What else is happening in the far edges of the solar system that we've yet to catch? James Webb Telescope detects something terrifying. Gigantic just collided with Neptune. But now the evidence points to something even more invisible, more insidious, and possibly more terrifying. The invisible hand of the solar wind, reshaping a planet's destiny from billions of miles away. Imagine this. Earth's magnetic bubble is a neat, round shield. Neptune's is a crooked, warped cage with giant holes in its walls. Every time the solar wind surges, it blasts straight through those holes, tearing at the atmosphere. It's like watching a storm batter a house where the roof is nailed on sideways.
Images so spectacular, even the astronomers could barely contain their excitement.
So maybe Neptune isn't just the victim of a single cosmic collision. Maybe it's just a world under constant attack from an invisible storm that stretches across space. And here's the disturbing question I want to leave you with tonight. If the solar wind is the source of the problem, then what does this really mean for Neptune's future? Will its atmosphere collapse completely? Are we going to see a planet gradually disintegrate in real time? But if the solar wind is responsible, then what's next for Neptune? And what terrifying changes might Webb uncover in the years ahead? The ice giant renaissance, what JWST reveals about our future. And here's where everything suddenly widens out, because what Webb is showing us on Neptune isn't just about one distant blue world spinning in the cold. It's a key to the biggest mystery in modern astronomy, the sub-Neptunes. These are planets that sit right between Earth and Neptune in size, and they turn out to be the most common type of exoplanet in the galaxy. We've found hundreds of them orbiting distant stars, and yet we barely understand them. They're too small to be gas giants like Jupiter and too big to be rocky Earths. They're the awkward middle child of the cosmos, and Webb's discoveries around Neptune are finally giving us a way to decode what these worlds are really like. Think about that for a moment. Every second, astronomers are spotting new exoplanets, and the ones that show up most often aren't Earth twins, and they're not giant Jupiters, they're Neptunes. If we want to know what alien planets look like, Neptune is the template, and now that Webb has pulled back the veil on its atmosphere, with those collapsing temperatures and strange auroras, we suddenly have a cosmic Rosetta Stone. What's happening over Neptune's south pole might be the same kind of instability rocking planets orbiting other suns. And here's where it hits closer to home. If these Neptune-sized worlds are the most common in the galaxy, and if their atmospheres are this unstable under solar winds, what does that mean for habitability? Could life ever take hold on a planet that lurches between freezing collapse and sudden heating? If Webb's right, then entire categories of exoplanets we once thought of as promising might be far more hostile than we ever imagined. But here's the flip side. Webb isn't done. NASA plans to monitor Neptune across the full 11-year solar cycle, the same rhythm that drives the sun's storms. That means we're about to watch an ice giant breathe in real time, through its seasons, its collapses, and its recoveries. And that kind of long-term surveillance will feed directly into our models of how planets form and evolve. Already, scientists are rethinking how worlds like Neptune are built, why they develop such tilted magnetic fields, and whether impacts or deep interior heat are the missing piece of the puzzle. The bigger picture? Webb isn't just telling us about Neptune, it's building a playbook. Every strange wobble in Neptune's skies gives us a clue for how to read the signals coming from sub-Neptunes light years away. When Webb catches methane vanishing from Neptune's clouds or temperatures swinging by double digits, It's training us to spot those same red flags in alien worlds.
At Neptune's rings, and these are some of the sharpest images that we've seen of Neptune in more than 30 years.
And that's why this matters for us, because in chasing Neptune's mysteries, we're really answering the oldest human question: are we alone? If atmospheres, this unstable, can never host life, then maybe we're rarer than we think. But if Neptune shows us how atmospheres recover, stabilize, and endure, then maybe the galaxy is full of worlds waiting for us to find them. So, when you hear James Webb Telescope detects something terrifying gigantic just collided with Neptune, remember that shockwave isn't just about Neptune's fate. It's the opening of an ice giant renaissance. And as Webb keeps watching, through every flare and storm, we're not just learning about Neptune, we're watching the birth of a whole new era in planetary science. As JWST continues monitoring Neptune through its full seasonal cycle, we're witnessing the birth of a new era in planetary science, and maybe, just maybe, the first real clues about where else in the universe life could take hold. Neptune's collapse, its crooked magnetic field, and the eerie way it dances to the sun's cycle aren't just curiosities, they're signals. Webb is showing us that atmospheres, even on giants billions of miles away, are fragile, alive, and constantly under assault. And this is only the beginning. NASA's plan to watch Neptune over the full solar cycle means the next revelations could be even more dramatic, maybe even rewriting how we think about habitability itself. So, what other secrets will Neptune spill? Could its fate mirror worlds we've yet to find? Don't forget to like and subscribe on our channel. Thanks.